Alright, welcome back to our client server basics in computer fundamentals, security path, and TryHackMe path, I guess we're gonna call it. Anyway, in this one we're gonna be talking about client server basics, so let's just jump right into it. In the previous rooms we looked at different types of computers and how computers are used to work. If you haven't seen that, I recommend you watch the entire playlist in sequence, because you want to follow like what we're doing, and you might be missing context if you're not watching them. I do have a playlist on my channel called Computer Fundamentals, or like TryHackMe Computer Fundamentals. Anyway, initially, most computers work alone. They stored their own files, ran their own programs, and did not communicate with other computers. Soon, multiple organizations around the world started with the idea of interconnecting these systems to facilitate information exchange and resource sharing regardless of distance. Hence, the precursors of the internet were born. Networks such as ARP-ANET, Cyclades, NPL, and NSFNet paved the way for the modern internet. Just like in society, where people distinguish themselves with a particular set of skills and offer these as a service, interconnected systems started to specialize as well. So how does this work? How are computer systems able to use services on another computer system? At the end of this room, you will know the answer to these questions. Cool. Understand the client-server model. Understand the following concepts on a surface level: DNS, client-server port, protocol, and network. Prerequisites inside a computer system, and then types of computers. These are not coming soon. We actually did these rooms on this channel in this playlist that I'm talking about. So this is incorrect. So just go watch these videos. Also, we covered most of these in our networking video, which is also mentioned in how networks work, or network basics. Also, you'll find a playlist on my channel for these. So we're going to be like going over these pretty quickly because we already covered them before, and I don't want to be repeating myself. But they are part of the room, so we'll be going through them. We're going to start with task 2, pizza delivery. One of the easiest ways to explain how computer systems provide service to other systems is to use an analogy. For example, how shops offer services to their customers. Let's have a look at the pizza takeaway. It's Friday night, and Alice and Bob feel like having pizza. Alice looks at Luigi's Pizza's menu and tells Bob which pizza she wants. Bob takes the car, enters Luigi's address into his GPS, and starts driving. Once Bob arrives, he enters Luigi's and places his order. Get me a large pepperoni pizza and a Coke. The employee acknowledges the order and starts making the pizza. Once the order is ready, Bob returns home and has a lovely pizza night with Alice. This seems like a standard, straightforward process, but don't be fooled, because we are so used to ordering pizza, we have internalized the process. Let's have a closer look at each step and relate it to how computer systems interact. So client and server, this is Alice, and then she's at Luigi's Pizza. Luigi's Pizza is the server. One large pepperoni pizza coming right up, request response. A protocol is an order, rules, and language for communication. A port is specific access point. And then you have a DNS, domain name and IP address, which is like their address, or like their location. In our analogy, Bob and Alice chose to use the pizza takeaway service. Alice is the client who passes her order to Bob, who then passes it to the server at Luigi's Pizzas. In computer terms, we can translate this as Alice using, for example, a browser to navigate to a website. The browser is the client that requests the web page, and the server is the system that serves it. Note that the client is the one who always initiates the request. Request and response. Alice requested a large pepperoni pizza from Luigi's. Be careful, this request was not made to Bob. Bob was the one who brought the request to Luigi's. What is important to realize is that if the request is not formatted correctly, or the requested resource is unavailable, we will get an error response. For example, Bob returns to Alice with the message that there were no pepperoni pizzas, or that the server did not understand the order. In computer systems, we can say that Alice used the browser, the client, to request a web page from a server, which then sent the web page to the client. Protocol. One of the things we don't often realize until we go on a trip to a foreign country is our language. When Alice formulates her request to Bob, she uses the language Luigi's Pizza understands. Additionally, Alice uses the menu to determine which order she can place. Bob understood the request, language, and order, and went to Luigi's to bring it. He received a response he understood and brought it back to Alice. We can compare Bob to a protocol that computer systems use to communicate. Protocol defines how a client communicates and so on, which commands do the client receives, the command how request is structured, the command and then the order, what syntax is used, Alice uses English language, what response should be given, a request of pizza, receiving the pizza, what response gives to faulty requests, no pepperoni pizza available, port. A port is used to identify a specific service running on a system. When a client wants to access service on a server, it must connect using the correct port. Yeah. Imagine that Luigi's takeaway service requires customers to enter through a specific door. Everyone ordering takeaway uses the same door. In the same way, a service on a server listens on a specific port. Exactly. So if you enter like even an IP address but use a default or like an incorrect port, you're not going to get a response, even if the service is available. DNS. When Alice sent Bob her request, only the name of the pizza place was known. With that alone, it's not possible to reach the destination. So Bob entered Luigi's Pizza into a GPS device, and the device returned the coordinates for Luigi's. This is the same as what DNS does. DNS translates domain names like google.com, facebook.com, whatever.com to an actual IP address, which is what we use in order to connect between servers. Or like on the network, to connect to the correct server that's going to service the website, we use an IP address. What do we use to identify a specific service on a server? It's a port. What do we call the address of a server? What do we call the address of a server? What is that? What do we call the address of a server? Is that the internet protocol address? Like the IP address? Yeah. Okay. Then let's do web communication in practice. So we did talk about HTTP in complete detail once we talked about that. So right now we are actually, to successfully complete this room, you need to set up your virtual environment. This involves starting the target machine, ensuring you're equipped with the necessary tools. So we have HTTP communication here. I will not go into HTTP and VPN and stuff like that because we are we did go through these like in depth in a dedicated tutorial. So we will not talk about these at all. What would be the host in the following URL? www.iamlearning.thm. What would be the scheme in the following URL? It's HTTPS. This is what is called the scheme, and this is the protocol. Now I understand what this is. What this is. Connecting, okay. Reload the page. You can see multiple get appearing. So these are the like checking the requests and the responses, I guess. Is what we're looking for. Oh, okay. I don't know where this came from. Oh, there we go. This looks like an yeah, Ubuntu's home. Looks like an Ubuntu machine running here. But that's okay. Let's go look into if there's anything that we have to do, actually. Probably not. I don't know why it's super laggy. Usually these machines are super cool. If you open DevTools network, you will see this. So we can click on inspect. let's dog this to the right. Then if you click on network, you can click reload, and then you are gonna see like all of the requests here that are coming in. And then we can have style.css. If you click on this and click on response, you will see the actual content of these CSS. And then if you click on JavaScript, if you click me, JavaScript loaded via get, and then you can see a request for fav icon, which does not exist. This request is done automatically, trying to fetch the icon that appears here in this area. For example, like this icon right here for TryHackMe. This is called the fav icon. And then here we have that stuff. And if we look at script.javascript, console.log, script.js loaded via get request, document the get element by ID, button, add event listener click. So basically that means whenever we click on the button that has an ID of button. So if I click inspect on this button, you can see that it has an ID of PTN. I don't know if you can see that well enough or not on recording, honestly. I think it's okay. So yeah, once we have that, I don't care about the console.log here. So then it's going to just alert JavaScript loaded via get. So when we do that, we get this alert box right here, which is just this JavaScript function. We could also, this is the response payload. So this is like a deep dive into an HTTP request and response. So you could look at these in any website that you would have. If you're using Chrome, you can right click and then open developer tools. Or if not, you could just use Firefox inspect, just like we're doing. So this looks like we got it. In this room, we have explored devices on the internet, stuff like that. So this is all good to go. We are processing to go to the next room, which is going to be virtualization basics. This is going to be a fun one because you need to understand virtualization to set up like Kali Linux and to set up tools and machines that we're going to use as labs, so as like practice points, so we can practice our skills, and also to set up something like Kali Linux, which is going to be our main tool that we use for doing penetration testing, which we're going to get into as we progress through these. So thank you for watching. I'm going to post this as a video because this is what I've been doing. Every lab or every whatever this is called, like module, is going to be its own video. Thank you for watching. Give me a like, give me a subscribe, give me any kind of constructive criticism that you want to see things specific in these videos. Let me know in the comments. And yeah, all I'm trying to do is to give you education. I learned everything that I know from the community, and all I'm trying to do is give back to the community. So thank you for watching, and I will see you in the next one. See ya.